the second part of the video, and let's take a look at it now. So again, they're giving us a slope and we're giving it a point. So we have to use our formula that I told you was very important. And remember, it goes to something to the effect of, well, actually right to the effect of, up you go, pen. It doesn't even want to listen to me. So y equals m bracket x minus x1 plus y1. Remember, I'm going to substitute my slope in here, and this is my x1 and my y1. So when I substitute those in, I end up with 0 times x minus 2 plus 6. Now, I have 0 times this bracket. 0 times anything equals 0, right? Because it'd be 0 x's, and 0 times negative 2 is also 0. So what I end up finally is y equals 6. So in this case, you don't even see an x in the equation. And that is because of this. It's one of the special ones. If the slope is 0, then it's a horizontal line with an equation y equals a number. So if I see m equals 0, I don't even have to go through all this process. I know it's going to be y equals a number, and the number it's going to be, it will be the y coordinate of the point they give me. Okay, so let's try another example. Here's with 1/3. So if I have 1/3, again, I copy down my formula. I'm going to substitute my slope in, which is 1/3, which I know you just love working with fractions. Notice they don't disappear just because you don't like them. So -2, and this is a negative, so this is going to be a +2, and my y1 is +7. So again, I must distribute my 1/3 inside that bracket. So I end up with y equals 1/3 x plus 2/3 plus 7. So now really the question I have to work on, the work, is the 2/3 plus 7. Okay, so what I'm going to do is I'm going to put 7 over 1 to turn it into a fraction. And we know that we need, when we're adding fractions, common denominators. So I'm going to multiply the 1 by 3, which means I must multiply the 7 by 3. So we end up with 2/3 plus 21 over 3 to give us a grand total here of 23 over 3. So we're going to replace this into our equation. 1/3 x plus 23/3. Okay, so really you see me use this technique a few times. I take out the stuff that I want my brain to focus on. So I need my brain to focus on adding fractions. So I take it out of my solution, because this is my solution, and I work on it over here, and then I bring it back in. Okay, so there's a couple examples there for you too. Um, and I'm going to actually add another one in here. And the reason, because I have this kind of question, but what happens if I have an undefined slope? So say for instance I have, and I'm going to change my color here to a different one obviously, and extend my page. What if they tell me that my slope is undefined? So my slope undefined, and the point let's say -5, 2. So I can't really use this formula for that because how do I put undefined in for my m? It just doesn't work. So it's kind of leaves you with a dilemma, but at the same time, let's think about it. It's one of these special ones again. Special in the sense that undefined slope means that I have a vertical line. So that vertical line is going to cross my x and y axis where? Well, it's always going to cross, and I'm literally going to take it, it's going to cross the x-axis. You can see somewhere along the x-axis. It might actually turn out to be the y-axis, but it crosses the x-axis. So when I have a situation like this, I know that my equation is going to be y does not equal a number this time. It's going to be x equals a number. And the number it's going to equal is going to be the x coordinate of the point they gave me. Okay, so this example and the one when the slope is equal to 0 are again those special lines. Notice they come up quite a few times because they're a little bit different than the other lines that have a slope that's that's a number other than 0 or undefined. Okay, so just watch out for that as well.